हेलो एंड वेलकम बैक। सो नेट एग्जाम में जो भी क्वांटम मैकेनिक्स के रिलेटेड क्वेश्चंस आए थे वो हम डिस्कस कर लेंगे। द फर्स्ट क्वेश्चन इज कंसिडर अ पार्टिकल इन अ वन डायमेंशनल infinite potential well between x greater or equal to 0 less or equal to L. If a small perturbation v of x equals to lambda cos of pi x by L, where lambda very less than 1 is applied, the first order energy correction to the ground state is. Okay, so first order energy correction E1 of 1 we know is given by the expectation value of the perturbation. So expectation value of the perturbation. So psi naught of 1. We, so psi naught of 1 is the unperturbed ground state. So unperturbed, perturbed ground state eigenfunction, ground state eigenfunction. Right. So if we can solve this expectation value, and we also know psi naught of 1, that is the unperturbed ground state eigenfunction, that's given by under root 2 by L sine of pi x by L. So let's just put this into this, and we also know V, so it's simple to solve. So E1 of 1 equals to integral 0 to L. So psi, let's just write it like this, 0 to L, 2 by L will be taken out. Then we will have sine square of pi x by L. Then V, so we'll have lambda cos of pi x by L, cos of pi x by L dx. So 2 lambda can be taken out of the integral, and this integral will be 0 between 0 to L. So as you can see, it's also an odd function, so it will be 0. So the answer will be 2. The next question is, a particle of mass m is in a cubic box of side A. The potential inside the box is 0 and infinite outside. The particle is in eigenstate with energy E equals to 7 pi square h square by ma square. A possible wave function is, so we had to say which among the following is the correct wave function for this particle in a box. So we have the energy that is given as energy eigenstate equals to 7 pi square h square by ma square. Now because it's a particle in a box, so box, so we have a box, and for box we know what are the energy eigenstates. So energy eigenstates we can write E equals to nx square plus ny square plus nz square pi square h square by 2 m a square. So this is the general energy eigenstate for a box. So which is goes to this thing, right? So we just have to equate it. So that means nx square plus ny square plus nz square pi square h square by 2 m a square equals to 7 pi square h square by m a square. So it implies nx square plus ny square plus nz square equals to 14. Now we have to find the nx, ny, nz sum such that the sum of squares equals to 14. So one possible combination is nx equals to 1, ny equals to 2, nz equals to 3. Simple. Such that 1 square plus 2 square plus 3 square will be equal to 14, right? So this is the possible combination 1 2 3. So that means our wave function will be psi will be equals to 2 by a 3 by 2 sine of, so in place of nx we have 1, so pi x by a, then we have sine of ny के बदले we have 2, so 2 pi x by a, and then we have sine of nz, so in place of nz we have 3 pi x by a. So this is our possible wave function. All right. So that means option number 1, 2, 3. This one. The next question is an electron is in the spin state psi given by 1 by 5 3I4 in the SZ basis. A measurement of Sx is made on the state. The probabilities of getting h cross by 2 and minus h cross by 2 are. So psi is given in the SZ basis, and then we have to find the probabilities of getting h cross by 2 and minus h cross by 2 when a measurement is made in the Sx basis. So first of all, let's write our psi in the SZ basis. So it's 1 by 5 3I4 because it is in the SZ basis, so we can break it down and write it like 3I by 5 10 plus 4 by 5 01. Okay, and here coefficient, so this coefficient equals to A and this coefficient equals to B. Okay, now we have to find the probabilities of getting h cross by 2 and minus h cross by 2, not in the SZ basis but in the Sx basis. So for that we have to write psi in the Sx basis. So we know it is given by a plus b by root 2 pi x plus, and then plus will have a minus b by root 2 pi x minus. Okay, and if we want to find the probabilities of getting h cross by 2, that is the square of this coefficient, and probability of getting minus h cross by 2, that is square of this coefficient. So what is the probability of getting h cross by 2? That means we had to do square of this. So that means 1 by 2 a plus b whole square. Now we know a, we know b, so that means 1 by 2 a plus b will be equal to 3I plus 4 by 5 whole square. That's equals to 1 by 2 3 square 9 4 square 16, that will 25 by 25, that is equals to 1 by 2. Similarly, if you find the probability of getting minus h cross by 2, that will also turn out to be 1 by 2. So we have two probabilities, 1 by 2 1 by 2, and the option is 3. The next question is, so actually this question is not as such from quantum mechanics, but they just put it here. So the constant b which makes this function an eigenfunction of this operator, okay, is, so we have to find the constant b. So by definition, d square by dx square minus bx square operating on e to the power minus ax square should be equal to some lambda, that is some constant times the same function minus x square. Okay, so we just have to operate this on this, that's it. So that means we have to basically operate this double derivative first. So d square by dx square operating on e to the power minus ax square, so it equals to d by dx of minus 2ax e to the power minus ax square. All right, so we'll have minus 2ax minus 2ax e to the power minus ax square plus e to the power minus ax square. All right, so it implies minus 4a square x square minus 2a, then we have the common exponential term. Okay, now we had to add the first term that we left out, that was this minus bx square, also minus bx square e to the power minus ax square should be equals to lambda times e to the power minus ax square, right? Now we have, so if we write it like this, so 4a square x square minus 2a minus b x square, then we have the common of this exponential factor e to the power minus a x square equals to lambda e to the power minus a x square. Now I have the common exponential terms on the both sides. So that means we have to only equate the coefficients. So now see here, because we have only the constant on the left hand this right hand side, so that means this has to be constant. So for this to be constant, the x squared coefficient must be equal to 0. So that means 4a square minus b should be equal to 0. So it implies b equals to 4a square, which is option number 1. So one more question from quantum mechanics was, a particle of mass m moving in one dimension is subject to the potential v of x equals to v naught delta function when x greater than 0 and less than t away. Otherwise it is infinity. So we have a situation like this. So we have a one dimensional potential. So when x is x does not lie within 0 and 2a, we have infinite potential, and within 0 and 2a we have a delta function. So let us do delta function at x goes to a. Okay, x goes to a, we have delta function. So something like this. So we have delta function at x goes to a. Have 0, x goes to 2a, and x goes to a. And let us suppose two regions here. So this is region number 1 and region number 2. What we have to find? We have to find the energy eigenvalues E such that they satisfy any of these options. Okay. So let's just write the wave functions first of all. So wave function in the first region, psi1 will be, suppose, let's just suppose it's given by a sine of kx, and in the second region it is given by b sine of kx. Okay, and while we know k from the Schrodinger equation, it will be simply given as, or we can write k square equals to m e by h square. So we know this. Okay. Right. Now, for this wave function, we know it must be continuous at x goes to a. So that means psi 1 at x goes to a should be equals to psi 2 at x goes to a. So which implies a sine of ka must be equals to b sine of ka. Right. So that means simply a equals to b. So let's just put it in the box. Now, one more condition which this infinite delta function imposes on the wave function is that the difference in the uh, first derivative is non-zero. So that means del of psi second dash minus psi first dash equals to minus 2m v naught h square psi at x goes to a. So we know this from delta functions. So they always impose some discontinuity in the first derivative, right? And it is given by this formula. Now what we have to find? We have to calculate the derivative, and then this derivative, and take the difference, and then equate it to this. Okay. So now what is psi dash second? Psi dash second equals to p k sine of kx. Similarly, psi dash of first function equals to a k. Oh, it will be cos. Sorry, it will be cos. Okay, it will be cos. It will be cos. So bk cos of kx, and for the first function also, it will be ak cos of kx. Now, this condition has to be applied at x equals to a. So that means, okay. So that means b k cos of kx cos of k a plus minus a k cos of k minus. So a plus means I'm going, so while we have the delta function this side and this side, so this will be a positive side, this will be a negative side. Okay, so actually a plus means a plus some little increment, and a minus means a minus del, right? So this equals to minus 2 mv naught minus 2 mv naught by h squared psi at x equals to a. So we can put any of the function a sine of k, suppose a sine of ka, right? Now we know a equals to b, so we can cut it out. So we have simply k cos of ka positive minus k cos of ka negative equals to minus 2 m v naught by h square and sine of ka. Now what about this thing? So this will be equal to simply twice k cos of ka. Why? Now let's just take one simple example here. So suppose we have a delta function and we know its function is given by uh, so something of this sort. If we have symmetric function, then if we take derivative at this, at the left right hand side of origin, it will be like this, and at the left hand side of origin it will be this. So they will have equal magnitude but opposite in direction, and it will be given by twice k of cos of ka, which will be equals to minus 2m v naught by h square sine of ka, right? So it implies 2 cancels out, so we'll have um so let's take k here, so we'll have cos of ka equals to minus mv naught by h square k sine of ka, or reshuffling it, we'll have tan of ka equals to minus h square k by mv naught. So we know what is k, so it will be tan of a. So remember k square equals to m e by h square. So k will have under root 2 m e by h cut. Then we'll have on the right hand side as minus h square by m v naught, and k will write m e by h cut. So finally we'll have tan of a of m e by h cut equals to minus um, h cut by v naught under root 2 e by m. So this will be our final answer. And if you look at the options, it's option number 3. So the another question from quantum mechanics was, a particle of mass m is bound in one dimension by the potential v of x equals to v naught delta function with v naught less than 0. If the probability of finding it in the region mod of x less than a is 0.25, then a is. So we have the delta function. So let's just say this is x and this is v of x. Then we have the delta function at the origin. Okay, so like this. So this is the delta function at the origin. Because it is strength, so v naught is its strength is less than 0. So it's the upside down delta function like this. Now mod of x less than a means x greater than minus a less than a. So it will be, suppose, from this minus a to a. So we know the probability of finding the particle in this region, and it's 0.25. 0.25. We have to find what is the value of A. Now we know psi is given by under root m v naught by h cut e to the power minus um, m m v naught mod of x by h cut square. So this is the wave function for the log delta function at x equals to 0, right? And if we want to find the probability, so that is given by psi square. Psi square gives the probability. Now why to find the probability of finding it in the region mod x less than a? So that means integral minus a to a mod square of psi dx, that is given by 0.25, right? So we can break it down because we have the mod function, so we can write twice 0 to a, then we'll write out psi. So it will be m v naught by h cut square e to the power minus 2 m v naught x by h cut square dx equals to 1 by 4. So it implies m v naught by h cut square integration will have e to the power minus 2 m v naught x by h cut square, and we'll have a factor as minus h cut square by 2 m v naught, which equals to 1 by 4. And then now 2m v naught and 2m v naught will get cancelled out, h square will get cancelled out, so we'll have 0 to a. So we'll have minus e to the power minus 2m v naught x by h cut square from 0 to a equals to 1 by 4. So it implies minus e to the power minus 2m v naught a by h cut square minus 1 equals to 1 by 4. It implies 1 minus e to the power minus 2m v naught a by h cut square equals to 1 by 4. And if we solve it further, we'll have 1 minus 1 by 4, that will be 3 by 4 equals to e to the power minus 2m v naught a by h cut square. And if we take ln on both sides, so ln of 3 by 4 equals to minus 2m v naught a by h cut square, or we can say a equals to taking the positive value only, so h cut square by 2m v naught ln of 3 by 4. So this is our answer, and it is option number 2. The last question from quantum mechanics was, for a system of two electrons, define an operator A equals to 3 by a square s1 dot a s2 dot a minus s1 dot s2, where a is an arbitrary vector and s1 and s2 are spin operators. The eigenvalues of a are, so we have two electrons and we have this operator, right? And we have to find the eigenvalues of this operator A. So to simplify, we know two electrons can be in any of these states. It can be up, up, it can be in down, down, or it can be in this superposition state, that is up, down, plus down, up. Okay, this is also the possible state, and also one more possible superposition state is up, down, minus down, up, 1 by root 2. Okay, so these are the four possible um, states: up, up, this superposition state, down, down, and this one. And corresponding to these four will have four eigenvalues. Four eigenvalues. Right? And so we know this. Now we have to find the eigenvalues for this operator A. So let's just say, right, A operator equals to 3 by a square s1 vector dot a vector s2 vector operator dot A minus S1 dot S2. Now to simplify this problem a bit, we'll assume that A is this A vector is in the Z direction, that is A in the ijk cap direction. Okay, so this will simplify our problem because it doesn't matter because A is a constant vector. So we'll have A equals to 3 by A square. It will become now S1 dot A vector will become SZ operator acting on first, then S2 will become SZ operating on second particle. Okay, so let me write Z in like this. We'll have SZ on first particle and SZ on second particle minus S1 dot S2. S1 dot S2. Okay, now S1 dot S2. What is S1 dot S2? Let's try to. S1 dot S2 is simply it's a dot product, so it will have SX S1X S2X plus. So I'm not writing this hat. Okay, just to make it more simple. So S1Y S2Y plus S1Z S2Z. Okay, so this we know. Now what we need to do is to operate this A vector on these four states. Okay, so what I will do before operating this A on these four states, I will give brief review of how these operators act. So we know Sx, if it acts on the up this eigenstate, it will what will be the eigen value? It will be h cross by 2 down. Similarly, Sx operating on down state, it will be h cut by 2 up. So this we know. Similarly, Sy operating on this up eigen state, it will be I to h cross by 2 down, and Sy operating on down will be minus h cut by 2 up, and Sz operating on up will be simply h cut by 2 up, and Sz operating on down will be simply minus h cut by 2 down. So this we know. So this we know from the spin uh, studies. So we just have to operate our A now. Okay. Okay. Now we have to take four any four states. So let's just take first of all this up. That is both the electrons are in the up state. So up. So our A operating on this state will be, so A operating on this up state will be 3 by A square SZ1 S2Z minus S1. Okay, let me write it like this. Okay, let me break it down. So I know I have up state. So first of all, I will act this part, this part. Okay, S1 dot S2, that is equals to this thing. So we'll have Sx1 S2 X plus S1 Y S2 Y plus S1 Z S2 Z operating on up. Okay, so it implies when this will act on this state, obviously S1 will act on the first electron and S2 will act on the second electron, and in our case both electrons are in the up state, so it doesn't matter. So we'll have H cut by 2 up, H cut by 2 up. Okay, plus now this operator will act, so we'll have iota H cut by 2 No, sorry. So we'll have, because now Sx is operating, so it will be h cut by 2 down, h cut by 2 down, h cut by 2 down, plus now this will act on this, so we'll have iota h cut by 2 down, iota h cut by 2 down, plus now sz operators will act on this, so we'll have h cut by 2 up, h cut by 2 up, right? So if we simplify it a bit, so we'll have h square by 4 down down minus h square by 4 down down plus h square by 4 up up. So it implies this and this will cancel out. We'll have simply h square by 4 up up. Okay, so we have simplified this s1 dot s2 for up state. Okay, now what remains is this s1z and s2z, s1z and s2z, again operating on up, so it will become we'll have h cut by 2 up, and then we'll have h cut by 2 up, so it will simply h square by 4 up. Okay, so we have both the terms, h square by 4 up, and we have here h square by 4 up. Okay, so if we substitute now here, now, so we'll have simply a vector, sorry, a operator acting on up will be simply 3 by a square. Now we calculated this one, so it was h square by 4, h square by 4 up, and we'll have a also, a square also. Okay, minus h square by 4 up, right? So a square cancels out, so we'll have 3 by 4 minus 1 by 4 h square up. So it is simply 2 by 4 h square up equals to 1 by 2 up. So in terms of h square, because question says in terms of h square. Okay, so for this eigenstate, the eigenvalue in terms of h square is 1 by 2. Okay, now if we calculate, suppose for down, eigen will have 1 by 2, right? So if we just go through it, we'll have down will have 1 by 2 for down also. Now if you check the answers where we have 1 by 2, it's the fourth option. Also you can check for this one and this one, and you will get 0 for this one and -1 for the other eigenstate. Okay, so 1 by 2, that means option number 4.